Hey everyone, welcome to this session on solutions. I'm excited to help you understand this important chapter for your JEE exam. Did you know that the air we breathe is actually a solution? It's a mix of gases. Understanding solutions is crucial not just for chemistry but also for real-world applications. So, let's dive in. First, what exactly is a solution? Simply put, it's a homogeneous mixture of two or more substances. Solutions are super important for JEE because they form the basis for understanding chemical reactions in liquids. Plus, you can expect a good number of questions from this chapter. Now, let's talk about concentration. Concentration tells us how much of a solute is dissolved in a solvent. We usually express concentration in molarity, molality, and mole fraction. Molarity is the number of moles of solute per liter of solution. Molality is the number of moles of solute per kilogram of solvent. And mole fraction is the ratio of the number of moles of one component to the total number of moles in the solution. Let's define these precisely. Molarity is the number of moles of solute dissolved in 1 liter of solution. It's temperature dependent because volume changes with temperature. Next, we have Raoult's law, which is super important for understanding vapor pressure. Raoult's law states that the vapor pressure of a solution is directly proportional to the mole fraction of the solvent. This law is essential for understanding ideal and non-ideal solutions. Here's the formula. P equals P0x, where P is the vapor pressure of the solution, P0 is the vapor pressure of the pure solvent, and X is the mole fraction of the solvent. Remember that this law applies to ideal solutions. Now, let's dive into colligative properties. These are properties of solutions that depend only on the number of solute particles, not their identity. The main colligative properties are relative lowering of vapor pressure, elevation of boiling point, depression of freezing point, and osmotic pressure. Let's look at the formula for elevation of boiling point. Delta Tb equals Kb*m, where delta Tb is the elevation in boiling point, Kb is the abelioscopic constant, and m is the molality. Always remember that colligative properties depend on the number of solute particles, not what those particles are. A common mistake is forgetting to account for the Van 't Hoff factor when dealing with ionic compounds. Now, let's work through an example. Question. 2 grams of benzoic acid is dissolved in 25 grams of benzene shows a depression in freezing point equal to 1.62 K mole. Depression constant for benzene is 4.9 K kg per mole. What is the percentage association of the acid if it forms a dimer in solution? Answer. Step 1. Calculate the molar mass of benzoic acid, C6H5COOH, equals 122 grams per mole. Step 2. Calculate the observed molar mass using the formula delta Tf equals I*Kf*m. Step 3. Calculate the Van 't Hoff factor, I, using the observed and theoretical molar masses. Step 4. Determine the degree of association, alpha, using the equation I equals 1, 1 to 1, n, alpha, where n equals 2 for a dimer. Step 5. Calculate the percentage association. The answer is approximately 99.2%. Think about how osmosis is used to purify water through reverse osmosis systems, giving us safe drinking water. Colligative properties are also crucial in many biological systems. So, keep an eye out for these common exam traps. Remember to account for the Van 't Hoff factor, especially for ionic compounds. Also, pay attention to units, molarity versus molality. Finally, practice applying the formulas to different types of problems. To recap, we covered concentration terms, Raoult's law, and colligative properties. These are the key concepts you need to understand for your JEE exam. All of this, AI notes, doubt solving, and practice tests for solutions, is available for free on Synapse. So study smarter, not harder. Start free today at synapse.omups.in to master solutions for JEE. Please subscribe to our channel for more free lessons. Visit synapse.omups.in and start learning today.